August 1944. The fields near Falaise, France, were burning. The Wehrmacht mechanics had been retreating for 3 days straight, dodging Allied artillery that screamed overhead every 15 minutes. Their convoy of Opel Blitz trucks limped through the smoke-choked countryside, engines overheating, transmissions grinding. They were running on fumes and desperation. Then Sergeant Klaus Hoffmann spotted it. Abandoned in a ditch beside a bombed-out farmhouse sat a massive American truck, its olive-drab paint barely visible beneath layers of dust. The vehicle dwarfed their standard Opel Blitz trucks. It looked untouched, intact, almost inviting. This is the forgotten story of how German mechanics discovered that they had already lost the war, not on the battlefield, but in the factory. This is the story of the GMC CCKW, the truck that proved American industrial might would crush the Third Reich. The mechanics approached the truck cautiously. These men weren't combatant soldiers. They were technicians, men who understood machinery the way a watchmaker understands springs and gears. Hoffmann had worked at an Opel factory before the war. His hands were permanently stained with engine oil. He knew trucks. He understood tolerances and specifications. He had spent years learning the intricacies of German automotive engineering. His unit was part of the 716th Infantry Division, assigned to maintain vehicles and keep the retreat moving. They had 7 Opel Blitz trucks left from their original complement of 23. The others had broken down, been destroyed, or simply abandoned when repairs became impossible. Parts were scarce. Every breakdown meant scavenging components from other wrecks. The American trucks sat there like a prize, or a warning. Hoffmann wasn't sure which. What he saw when he opened the hood made him stop breathing. The engine was enormous. A straight 6-cylinder GMC 270 cubic inch motor sat there like a sleeping giant. But it wasn't the size that shocked him. It was the simplicity. Everything was accessible. The spark plugs were easy to reach. The oil filter could be changed in minutes. The air filter housing had just 4 bolts holding it in place. Hoffmann's hands trembled as he examined it. On an Opel Blitz, changing spark plugs required removing half the engine cowling. The air filter was buried beneath layers of components. German engineering valued precision. Every part was machined to exacting tolerances. Every bolt had to be exactly the right torque. It was beautiful engineering, the kind that made German mechanics proud. But this American engine was different. It was crude. The tolerances were loose. The parts looked mass-produced, stamped from sheet metal rather than carefully machined. Yet somehow it worked. More than that, it worked reliably. Corporal Werner Schmidt opened the toolbox mounted on the running board. Inside he found a complete set of standard wrenches, all the same size family. On their Opel trucks, every bolt seemed to require a different specialized tool. The Americans had standardized everything. Any mechanic with basic tools could work on this monster. Then Schmidt found the manual. It was printed on thick quality paper. The pages were filled with detailed illustrations showing every component, every repair procedure, every potential problem and its solution. The diagrams were so clear that someone who couldn't read English could still understand them. Schmidt had seen German technical manuals. They were precise, thorough, filled with dense technical language that required an engineering degree to comprehend. This American manual was different. It was designed for the average soldier. Pictures showed exactly where to put the wrench. Step-by-step instructions walked through every procedure. It assumed the mechanic was competent but not an expert. This was engineering for mass armies, engineering for millions of men who had never set foot in a factory before the war. The GMC bore markings indicating it was a model CCKW 353, manufactured in 1943 at the Pontiac plant in Michigan. The acronym told its own story. The first C meant it was designed in 1941, the second C indicated a conventional cab. K meant all-wheel drive, W meant dual rear axles. It was a naming system designed for logistics, for keeping track of hundreds of thousands of identical vehicles. Hundreds of thousands. The number made Hoffmann's stomach turn. Later that evening, the mechanics got the GMC running. It started on the second try despite sitting abandoned for who knows how long. The fuel system was so simple they had it primed in minutes. The battery was massive, providing plenty of cranking power. The starter motor engaged with a confident roar. They drove it back to their temporary encampment. The difference was immediately apparent. Where their Opel trucks struggled through muddy roads, the GMC powered through effortlessly. The six-wheel drive system distributed weight perfectly. The suspension was crude but effective, absorbing ruts and holes that would have rattled an Opel to pieces. The truck could carry 2.5 tons of cargo. They loaded it with spare parts and supplies. It didn't complain. The engine maintained steady power even under load. The Warner T93 5-speed transmission shifted smoothly. There was even an overdrive fifth gear for highway cruising. That night, the mechanics sat around a fire and talked. Supply officer Lieutenant Friedrich Weber had been compiling notes. He was an accountant before the war, a man who understood numbers. Weber laid out the mathematics of their situation, and it was terrifying. Each American infantry division had approximately 2,000 trucks. The Americans had 40 divisions in France. That meant 80,000 trucks just supporting combat operations. And that wasn't counting the Red Ball Express, the massive supply convoy that was feeding the Allied advance. The Germans, Weber explained, had maybe 100,000 trucks across all fronts, total. They had 3 million horses pulling wagons and artillery pieces. 3 million horses, like something out of the Napoleonic Wars, while the Americans moved everything by the motor. But the numbers got worse. In 1943, Opel had produced approximately 27,000 Blitz trucks. That was Germany's best output from their most efficient manufacturer. Weber had heard rumours from intelligence reports. The Americans had built over 100,000 GMC trucks in that same year. 100,000 from a single manufacturer. And GMC wasn't even the only company making trucks. Studebaker was producing similar vehicles. So was International. Dodge was churning out lighter trucks by the tens of thousands. The entire American automotive industry had converted to military production. The accountant's mind couldn't escape the implications. The Americans were outproducing Germany by a factor of 10 to 1, maybe more. Hoffman examined the truck's construction more carefully the next day. The body panels were stamped steel, crude but functional. They showed tool marks, slight imperfections. German manufacturers would have rejected these panels as substandard. But here they were, doing their job perfectly well. He ran his hand along the fender. The metal was thicker than necessary, deliberately over-engineered for durability rather than weight savings. A German engineer would have calculated the exact thickness needed and used that, saving weight and material. The Americans just used thick steel because they had plenty of it. The welds were functional but not beautiful. In a German factory, welders took pride in their work. Clean beads, perfect penetration, aesthetically pleasing joints. These American welds were strong enough but showed little artistry. They were done by workers who had been trained quickly, probably during the war, who could make an adequate weld in half the time a German craftsman needed for a perfect one. It was a philosophical difference that extended through every aspect of the vehicle. German engineers optimized. They found the mathematically perfect solution, the most efficient design, the ideal balance of weight and strength. It took time, it took expertise, it produced magnificent machines. American engineers simplified. They found solutions that worked well enough, that could be implemented quickly, that didn't require expert craftsmen to build. It produced adequate machines in overwhelming numbers. The cargo bed was made of wood. Not fancy hardwood, just standard lumber, the kind you could get anywhere. When steel became scarce, the Americans simply switched to wood. When wood proved unsatisfactory, they made a composite bed with steel framing and wooden slats. They adapted. They didn't let perfect be the enemy of good enough. The canvas top was commercial-grade fabric, nothing special, nothing engineered. Just a waterproof cover that did its job. You could replace it at any supply depot, anywhere in the world. This was the philosophy that was destroying them. The Americans didn't care about making the perfect truck. They cared about making a truck that worked, that could be built quickly, that could be repaired by anyone, anywhere. Schmidt discovered something that made the situation even clearer. He was examining the axles when he noticed the part numbers. The front axle and rear axle used interchangeable components. Many of the parts were stamped with the same manufacturer codes he had seen on Chevrolet vehicles. The Americans had standardized across manufacturers. A GMC truck could use Chevrolet parts. A Studebaker could use International parts. The entire supply chain was unified in a way the Germans had never achieved. Germany had over 100 different vehicle types in service. Each manufacturer guarded their designs jealously. Each vehicle required unique parts. The logistics nightmare this created was incalculable. Supply depots had to stock thousands of different parts. Mechanics had to be trained on dozens of different systems. The Americans had maybe 10 standardized vehicle types for the entire army. Every mechanic could work on any vehicle. Every supply depot could support any unit. It was so obvious in retrospect, so simple. Why hadn't Germany done this? The answer, Weber knew, was pride. German engineering was the best in the world. Everyone knew it. German craftsmen didn't make crude stamped parts. They made precision machinery. Every Opel Blitz was a testament to German engineering excellence. But excellence took time. It took skilled workers. It took resources that Germany didn't have. Germany's production was constrained in ways the Americans simply weren't. The Opel Brandenburg plant had been built specifically for military truck production in 1935, constructed in just 7 months to meet Wehrmacht demands. At its peak, it produced 2,600 trucks per month. That sounded impressive until you compared it to American output. A single Ford plant, the Willow Run facility in Michigan, was larger than the entire Brandenburg works. It employed 42,000 workers on 3 shifts. The building itself was over 1 mile long. One facility producing more in a month than Germany's entire truck industry produced in a year. The Americans had started with a huge advantage. Their peacetime automotive industry was already the largest in the world. In 1941, before Pearl Harbor, American companies manufactured over 3 million civilian automobiles. 3 million. Germany's entire vehicle production for the military that year was maybe 40,000 trucks and cars combined. When America entered the war, those 3 million car production slots didn't disappear. They converted. The same assembly lines that made Chevrolets made GMC military trucks. The same workers who installed car seats installed truck beds. The infrastructure was already there. The know-how was already there. The supply chains were already there. Germany had to build its war production from a much smaller base. Yes, Opel had been producing trucks since the 1920s, but the scale was completely different. German production was measured in thousands. American production was measured in hundreds of thousands, and that gap was widening every month. The Americans had taken a different path. They had embraced mass production decades earlier with Henry Ford's assembly line. Their automotive industry was designed from the ground up for volume. When war came, they simply redirected that volume toward military vehicles. The GMC CCKW wasn't revolutionary. It was based on commercial truck designs from the late 1930s. The engine was a modified version of a civilian motor. The transmission was borrowed from commercial vehicles. The entire truck was an exercise in using existing technology and scaling it up to unprecedented numbers. Over the next week, the mechanics used the captured GMC for supply runs. It became the most reliable vehicle in their unit. While Opel trucks broke down, while transmissions failed, while engines overheated, the GMC just kept running. A supply sergeant who drove it daily noted in his journal that the truck was reliable in a way German vehicles simply were not. The German trucks were engineered for precision, tight tolerances. Everything had to be perfect, but perfect was fragile. In the mud and chaos of war, tight tolerances meant parts that seized up, that wore out quickly, that required constant maintenance. The GMC was built with loose tolerances. Parts rattled. The engine was noisier than a German motor. But it could take abuse. It could run dirty. It could operate in conditions that would kill a precision engine. It was engineering for war, not for peacetime. Hoffman spent an evening calculating production numbers from the serial numbers on captured American equipment. The numbers were staggering. By mid-1944, over 500,000 GMC CKW trucks had been built. 500,000. That was more trucks than Germany had produced in total across all manufacturers since 1939. But it wasn't just trucks. The same philosophy applied to everything. American tanks were crude compared to German panzers. The Sherman tank was mechanically simple, easy to maintain, easy to produce. Germany built Panthers and Tigers, mechanical masterpieces that required hours of maintenance for every hour of operation. The Americans built 5 Shermans for every German tank. When a Sherman was destroyed, another appeared the next day. When a Tiger broke down, it might be weeks before parts arrived, if they arrived at all. The aircraft told the same story. The B-17 bomber was designed for mass production. Standardized parts, simple systems. By 1944, American factories were completing a B-17 every 63 minutes. 63 minutes, from start to finish, a complete heavy bomber. Germany's best factories took weeks to build a comparable bomber, and they built a fraction of the numbers. The philosophy extended to everything. American rifles were mass-produced. American ammunition was standardized. Even American rations came in standardized packaging that could be produced by any food manufacturer. Germany had better individual weapons. German soldiers ate better food when they could get it. But the Americans had more of everything, and more kept coming every single day. Weber understood what his superiors did not. This wasn't a war that could be won by superior tactics or better training or fighting spirit. This was a war of industrial production, and Germany had already lost that war before. The first shot was fired. The American GDP in 1944 was nearly $1.5 trillion. Germany's was $466 billion. The United States was producing more than 3 times Germany's total economic output. American steel production dwarfed Germany's. American aluminum production was 10 times higher. American oil production made German synthetic fuel programs look pathetic in comparison. The mechanics saw this truth in the captured GMC truck. It wasn't just a vehicle, it was a symbol of an industrial machine that Germany could never match. In 1941, the United States manufactured over 3 million cars. When war came, those same factories that made cars started making trucks, tanks, aircraft engines. The assembly lines didn't need to be rebuilt, they just needed to be retooled. Workers who made Ford started making B-24s. The industrial capacity was already there, waiting to be redirected. Germany had no such capacity in reserve. Every factory was already working at maximum output. There was no slack to take up, no hidden industrial potential to tap. The Americans built more aircraft in 1944 alone than Japan built during the entire war. They launched more ships in 1941 than Japan's entire wartime production. By war's end, more than half of all industrial production in the world was happening in the United States. And there was another factor the mechanics didn't fully understand but Weber suspected. The American homeland was untouched. No bombs fell on Detroit. No artillery hit Pittsburgh's steel mills. American factories operated 24 hours a day, 7 days a week, with no interruption. Germany's factories were being bombed around the clock. The Opelwerk Brandenburg plant had been devastated by an RAF air raid on August 6, 1944. Production had moved to Mannheim, to Daimler-Benz facilities, but output had dropped dramatically. American factories just kept building. The Ford Willow Run plant was producing a B-24 bomber every 63 minutes, 24 hours a day, every single day. That plant alone outproduced Germany's entire bomber program. The mechanics began to understand something that many German generals refused to accept. Superior German engineering didn't matter when the Americans could field 10 vehicles for every German one. Better German training didn't matter when American pilots flew planes that were replaced overnight. Tactical brilliance didn't matter when you were drowning in American steel. The GMC truck represented something more profound than just transportation. It represented a different philosophy of war. The Americans understood that modern warfare was about logistics, about supply chains, about keeping armies moving and fed and armed. The famous Red Ball Express used 6,000 trucks, mostly GMCs, to haul 12,500 tons of supplies per day from the Normandy beaches to the front lines, 12,500 tons every single day. The convoy operated on one-way routes, northbound lanes carrying supplies forward, southbound lanes bringing empty trucks back. They wore out 50,000 truck tires in 3 months. 50,000 tires, but it didn't matter. The Americans had millions of tires in reserve. They had production capacity to replace anything that wore out. Germany couldn't match that. Germany didn't have the rubber. They didn't have the industrial capacity. They didn't have the raw materials. By late August 1944, as the Falaise pocket collapsed, the captured GMC truck had become the most valued vehicle in the mechanics unit. Officers fought over who could use it. It never broke down, it never overheated, it just kept running. One evening, Hoffman sat on the truck's running board, smoking one of the American cigarettes they'd found in the cab. The cigarettes came in standardized packs, millions, produced every day in North Carolina factories. Even the cigarettes were mass-produced to a degree Germany couldn't match. He thought about the factory workers in Detroit and Pontiac, in Cleveland and Los Angeles. They were building trucks while American soldiers fought. They were building so many trucks that losing a few hundred in France didn't even register. The production numbers just kept climbing. German factories struggled to maintain output as workers were conscripted, as materials became scarce, as Allied bombs fell. American factories expanded, more production lines, more shifts, more trucks. Schmidt walked over, holding the maintenance manual they'd found in the GMC. He'd been studying it, trying to understand the American approach to engineering. The manual showed every part, every specification, every repair procedure. It was designed so that anyone could fix anything. German manuals assumed expertise. American manuals assumed competence but provided all the information needed. Another example of engineering for the mass armies rather than elite troops. The two mechanics didn't speak for a while. They both understood what the truck meant. The war wasn't going to be won by German superiority. It was going to be won by American quantity. Overwhelming, relentless, unstoppable quantity. Weber joined them, carrying his notes. He'd been calculating the mathematics of industrial production. By his estimates, the United States was producing war material at a rate that exceeded the combined output of Germany, Italy, and Japan. American factories had produced nearly 300,000 aircraft during the war, 93,000 tanks, 2 million army trucks. The numbers were so large they became almost meaningless. How do you fight an enemy that can lose 1,000 tanks and replace them within a week? The answer was that you couldn't, not in the long run, not without industrial capacity to match. Germany's best hope had been to win, quickly before American industry fully mobilized. Blitzkrieg, lightning war, overwhelm the enemy before they could respond. But that window had closed by late 1941. Once America entered the war and its factories switched to military production, the outcome was inevitable. The mechanics understood this truth in August 1944. Their generals would take months or years to accept it if they ever did. But men who worked with machines, who understood production and logistics, they saw it clearly. The GMC CCKW wasn't just a truck. It was a rolling statement of industrial superiority. Every bolt, every stamped panel, every crude but functional component said the same thing. We can build these faster than you can destroy them. We can make more in a month than you make in a year. You cannot win. On August 21st, as the Falaise pocket finally closed, the mechanics received orders to retreat toward the Seine. They would use the GMC truck to carry their equipment and wounded. The Opel trucks had broken down or been abandoned. Hoffmann drove the GMC through the chaos of the German retreat. Bodies lined the roads. Destroyed equipment littered the fields. The Allies had killed or captured 50,000 German soldiers in the pocket. They'd destroyed hundreds of tanks, thousands of vehicles, but the American trucks kept coming. More GMCs rolled off the assembly lines in Pontiac. More supplies moved forward. The industrial machine didn't slow down. It accelerated. The mechanics would survive the war. They would spend time in Allied POW camps, often working in motor pools. They would see firsthand the scale of American production, the endless supplies, the casual abundance of a nation that could afford to waste what Germany rationed. After the war, some of these mechanics would return to Germany and work in the automotive industry. They would carry the lessons learned from that captured GMC truck. The importance of standardization, the value of simplicity, the power of mass production. But in August 1944, standing beside a captured American truck in the ruins of France, these mechanics understood that they had seen the future, and it was painted olive drab, built in Detroit and unstoppable. The GMC CCKW. Just a truck. 2.5 tons, simple engine, crude construction, but 572,000 of them were built. They served in every theatre of war. They supplied armies across 3 continents. They outlasted the German trucks, outlasted the war itself. Because sometimes good enough, built in overwhelming numbers, beats perfect. The American industrial machine didn't just win battles. It won the war before the first shot was fired. The factories of Detroit and Pittsburgh decided the outcome. The assembly lines that could produce a truck every few minutes proved unstoppable. Germany had superior engineering, better individual weapons, more experienced soldiers early on, but none of it mattered against American mass production. The mathematics was simple. You cannot defeat an enemy that can build faster than you can destroy. The Wehrmacht mechanics who captured that GMC truck in August 1944 learned this truth. They saw in its simple construction, its standardized parts, its mass-produced components the war's inevitable conclusion. They understood that Germany had already lost, not on the battlefield, but in the factory. The truck represented everything the Third Reich couldn't match: industrial capacity, raw materials, production efficiency, logistical excellence, the ability to build adequate equipment in overwhelming numbers. Every time a German soldier saw an American truck or tank, they were seeing proof of industrial superiority they couldn't overcome. Every time a mechanic opened a captured GMC's hood, they understood the war was lost. The genius wasn't in making the perfect truck. The genius was making a good truck that could be built by the hundreds of thousands, that could be repaired by any mechanic, that could carry weight, go where needed, keep running,